What this means is that our tangent line has a slope of 2 at the point 1, 0. So we use the general form y equals mx plus b again. We plug in the ordered pair for y and x, plug in our slope to solve for b. We find b equals -2. So our tangent line is y equals 2x minus 2. Okay, for problem 6. We are given that f of x equals x squared over x minus 1. Let's double check and see what the problem is actually asking for. 6 wants us to determine the point, or the points, the coordinates, at which the graph of the function has a horizontal tangent line. So that first one's actually just part A. But what we should notice is that if we're looking for a horizontal tangent line, that means that the slope is 0. So the derivative of the function must be 0. Okay. For part A, we have f of x equals x squared over x minus 1. We're going to use the quotient rule. We find that f prime of x equals 2x squared minus 2x minus x squared all over x minus 1 squared, which is actually x squared minus 2x all over x minus 1 squared. And we're going to set this derivative equal to 0. When that happens, we then see that x squared minus 2x must equal 0. We can factor out an x, and we find that x equals 0 or positive 2. So those are the x coordinates where our original function has a slope of 0. To find the actual ordered pair, we plug these values back into f. We find that f of 0 is 0 squared over 0 minus 1, which is 0. And f of 2 is 2 squared over 2 minus 1, which is 4. So our two coordinates are 0, 0 and 2, 4. Okay, for part B, we have f of x equals 4x minus 2 over x squared. Again, we pull this apart. And then we find that f prime of x equals 4x squared minus 8x squared, let's see, plus 4x all over x to the 4th. Which is equal to negative 4x squared plus 4x over x to the 4th. We set this equal to 0. We then find that negative 4x squared plus 4x equals 0. Factor out a 4x. So either x equals 0 or x equals 1.